Welcome to the Explainer. If you're looking to really master the art of web scraping, well, you're in exactly the right place. Today, we're diving deep into Playwright. It's rapidly become, honestly, the ultimate solution for automating data collection and browser interactions on the modern web. We're going to break down exactly how it works, why it's so incredibly powerful, and how you can start using it to extract exactly the data you need. So here's our progressive zero-to-hero journey for today. First, an intro to Playwright. Second, getting the environment set up. Third, basic browser automation. Fourth, extracting web data. Fifth, simulating user interactions. And finally, number 6, we'll cover scraping best practices. All right, let's kick things off with Section 1, Intro to Playwright, the modern automation engine. To put it simply, Playwright is this highly versatile, open-source Node.js library created by Microsoft. And what makes it so special? Well, it natively supports Chromium, Firefox, and WebKit right out of the box. But the real game changer here is its intelligent auto-wait APIs. You know, in the past, scrapers would just fail because a page hadn't fully loaded yet. So frustrating. But Playwright automatically waits for elements to be ready, actionable, and stable before it even tries to interact with them. Plus, it brings powerful element selection and seamless device emulation for those mobile-specific views. Moving right along to Section 2, Setting up the environment, your scraping blueprint. Now, before we can actually start writing automation scripts, we need the right foundation. That means Node.js and a solid code editor like VS Code. From there, it's literally just a few terminal commands. Step 1, just make sure Node and npm are installed on your machine. Step 2, run npm init-y to initialize a new Node project. And Step 3, the magic command, npm I playwright. That's going to install the library and all the required browser binaries so you're totally ready to scrape. Okay, Section 3, Basic Browser Automation, starting the engine. This is where the fun begins, writing our very first script and actually launching a browser using code. Now, by default, Playwright runs in headless mode. That basically means the browser runs entirely in the background, kind of like a ghost, without any visible user interface. And that is absolutely fantastic for speed and server deployments. But when you're just starting out or you're actively debugging, you're definitely going to want headed mode. That actually pops open a visible browser window so you can literally watch your code interact with the web in real time. Translating this into syntax is beautifully simple. Looking at the first line, it's just plain English logic. We're importing the Chromium object straight from the Playwright library. Next, we tell our script to launch that browser. And by passing in that headless false property, we're explicitly telling Playwright, hey, actually show me the browser window. Right, so once the browser's open, we actually need it to do something. These two commands are your absolute fundamentals for navigation and verification. Page.goto commands the browser to navigate to a specific URL, in this case, Google. And then page.screenshot tells Playwright to snap a picture of the fully loaded page and save it as google.png. This is so vital for just verifying that your script actually saw what it was supposed to see before you even try extracting data. Which brings us to Section 4, Extracting Web Data, diving into the DOM. Navigating around is great, but we're here to collect data, right? That means diving into the document object model to extract exact text. And Playwright gives us specialized methods to do exactly that, starting with page$eval. Notice the single $sign there. You use this when you want to pinpoint one single specific piece of data, like maybe a main article heading. It just finds the first element that matches your CSS selector and runs a quick JavaScript function to pull that data right out. Let's break down how this actually works in practice. We call page.eval, and we pass it two things. First, our CSS selector. Here, it's h1.c specific class. Playwright scans the page, grabs that specific heading. Then, the second part is just a tiny function, arrow function, l.textContent. This takes that HTML element, extracts the plain text from inside it, and saves it to our text variable. It's clean, direct, and incredibly fast. But wait, what if you need a whole list of items? That's where page.$evaluate comes in. Notice the two $signs this time. This method is absolutely essential for bulk extraction. So instead of stopping at the very first match, it collects every single element on the page that shares your selector, and then returns an array of extracted results. It's perfect for scraping things like lists of article titles, product catalogs, or maybe a directory of GitHub repositories. To actually execute this bulk extraction, notice how we target article.border, which might represent a list of, say, 20 different repositories on a page. Because we're dealing with multiple elements now, our function uses .map to iterate over the entire array of HTML elements, pulling the text content from each one. In just a single sweep, you've pulled dozens of data points into a neat, organized list. Okay, so extracting static text is pretty easy. But what if the data you need is hiding behind a form? Or what if it requires a load more click to even appear? Or demands that you log in first? Older scraping tools would hit a complete brick wall right here.
Let's solve that in Section 5, Simulating User Interactions, Acting Like a Human.
The cool thing is, Playwright doesn't just read code, it acts like a human. It easily bypasses static page limitations by interacting with the web exactly like you or I would. For instance, page.click can literally look for the exact text load more on a button and just click it to reveal more data. Need to run a search? The page.fill method finds an input box and types in your search term, like Playwright, exactly as if a real user was typing on a keyboard. But it goes even deeper into advanced, nuanced interactions. The page.hover method lets you trigger those tricky drop-down menus that only appear when a mouse rests over them. You can even simulate right clicks just by passing button right into your click command. This level of interaction is absolutely vital for accessing data on complex, highly dynamic modern websites. All right, final stretch, Section 6, Scraping Best Practices, the Professional Edge. Look, writing the script is really only half the battle. To scale your automation without getting your IP totally blocked, ethical guidelines and technical protections have to go hand in hand. Always respect a website's terms of service and check their robots.txt file. Crucially, you've got to implement rate limiting. Seriously, do not hammer a server with 1,000 requests a second. It overloads their systems and pretty much guarantees you'll get blocked. And finally, for large-scale collection, you absolutely must use rotating proxies. Let's define that clearly, just so we're on the same page. A rotating proxy is a network that automatically provides a new IP address from a massive pool for every single request your script makes. It's a mandatory architectural choice if you want to scale. Think about it. If you make 10,000 requests from your single home IP address, the target website will instantly flag you as a bot. A rotating proxy distributes those requests across thousands of different IPs, keeping your profile low and preventing those bans. Now, depending on the difficulty of the website you're trying to access, you'll want to route your API connections through different types of proxies. Residential proxies use real IPs from actual internet service providers, meaning they look exactly like everyday users and have the highest success rates for strict sites. Data center proxies, on the other hand, originate from cloud servers. They're lightning fast and great for sites with lower security. And then there are mobile proxies, which route traffic through real cellular networks, like 3G, 4G, or 5G. Those are incredibly difficult for anti-bot systems to block. And that brings us to the end of our journey today. You now understand how to set up Playwright, automate the browser, extract data, simulate human interactions, and scale the whole thing with professional proxies. You literally have the blueprint to automate the web. Thank you so much for joining this explainer. I guess the only question left is, what data are you going to extract first? Get out there and start experimenting.